Welcome to our channel Euclid Mathematics. In my today's video, I'm going to explain to you all one of the previous year question from Green's function. Okay, so we have to given first of all we have here boundary value problem. Then we have to find out whether Green's function is exist or not. And once we get the Green's function, then we have to solve given boundary value problem. Okay, it is little different than my previous video. Today's example, which is based on different cases of a Green's functions that we learned these cases in my previous lecture. Okay, so we have to apply such a cases here after getting boundary value problem, after solving boundary value problem, and then we get the Green's function, and then we have to apply these special cases to our problem. Okay, and this is question which is completely based on previous year question from group Green's function. So let's get started our today's question. I will explain to you all question and then we'll move for solution. Here in our question we have given the boundary value problem u double dash which is equal to negative of f. Okay, and u of 0 is the first boundary condition which is equal to 0. Second boundary condition u dash of 1 which is equal to 0 on closed interval 0 1, where u dash is a differentiation of a u with respect to x. U double dash is a double differentiation of a u with respect to x. Okay, and assume f of x is a real valued continuous function. Okay, we need a continuous function for Green's function on a closed interval 0 1. Then we have to figure it out which one of the option is correct. Okay, so this is the question which is from boundary value problem. We have to convert it into the Green's function. Okay, it is some special type case from Green's function. Okay, like if we have L of y plus phi of x which is equal to 0. If we take that negative f here to other side, you will get the u double dash plus f of x which is equal to 0. That means is the form of L of y plus phi of x which is equal to 0. Now let me explain the case also. So here we have case. It is second type of that case. So when we have boundary value problem like L of y plus phi of x which is equal to 0, then if you want the solution of our boundary value problem, what we have to do? We have to take y of x as the solution of a boundary value problem which is equal to integral over a to b, the limit which is given in our problem, which is equal to g of x t phi of t dt. Okay, so now you may get confused here. So what it is here, we have g of x t, but we get the g1 of xt and g2 of xt. So we have to apply limit a to t g1 of xt plus t to b g2 of xt. Okay, and out of bracket phi of t dt. Then you have to solve that integral. You will get the solution of our boundary value problem. For your practice, you may solve this question also. Y double dash plus y which is equal to x, y of 0 is equal to 0 and y of pi by 2 is equal to 0. You may solve this boundary value problem to Green's function and find out the solution of our boundary value problem by using condition second. So we have to apply that second condition to our question. Okay, now let's apply this condition. First of all, we will solve the boundary value problem and then we will apply this condition to our example. So here we have given boundary value problem y double u double dash. Instead of y double dash we have u double dash. Okay, this is just interchanging the values of y into u and u into y. Nothing is different than this. Okay, so we do not have to get confused. So u double dash plus f which is equal to 0. This one is the given boundary value problem with a boundary condition u of 0 is equal to 0 and u dash of 1 which is equal to 0. So these are the boundary condition along with that boundary value problem. And given function of the form, what the form of function is here, L of y, that means a double differentiation as we do in our Green's function regular problem. Okay, so we have to apply similar over here. So we have here L of y plus phi of x which is equal to 0, and L of y we have here y double dash. Instead of u double dash I taken y double dash because always we solve the example in the variable like y, so that's why I taken y double dash. So L of y is equal to y double dash and phi of x is here f of x. Okay, so f it is here. Now let's check this boundary value problem which exists trivial solution or not. If boundary value problem exists trivial solution, then we have to find the Green's function, because only then Green's function exists and unique there. Okay, So y double dash which is equal to 0, that means we have to convert that y double dash into the form of polynomial, like a d double dash which is equal to 0, that is a d square which is equal to 0. Find out the root which is a d which is equal to 0 0. Okay, d is having root 0 0, and when in our differential equation we got the root of a polynomial, root of equation is 0 0, then we write their solution y of x which is equal to c1 plus c2x e to the power mx. Okay, c1 plus c2x e to the power mx. M is the root, repeated root here. Okay, so when we have repeated root of our differential equation, c1 plus c2x in e to the power mx, e to the power 0x, which is a 1. Okay, so I got the y of x is equal to c1 plus c2x. Apply the boundary condition y of 0 and y dash of 1. Okay, so y of x is here, y dash of x will get the c1 c2 only. Okay, so y dash of x which is equal to c2, that means y dash of 0, y dash of 1 which is equal to 0. So y dash of 1 which is equal to c2, and put y dash of 1 is equal to 0. c2 is a 0 here. If c2 is 0 and y of 0 is equal to 0, then we'll get the c1 also 0. Using this one we get the c1 0. If c1 0, c2 0, okay, if c1 0, c2 0, put this value 0 0 in our equation. Okay, so c1x plus c2, so y of x will get the c1 0 0 and complete here total 0. Okay, so y of x which is coming 0. Now we may say that here. Okay, so if c1 got the 0, c2 got the 0, our equation, solution of our boundary value problem y of x which is equal to 0, that means our boundary value problem which is having solution trivial. And once a trivial solution exists for our boundary value problem, then we say that here Green's function exists and unique. And once Green's function exists and unique, there we have to find out the Green's function. Okay, and the main problem it is starting from there. So for your better understanding, you may refer this solution. Okay, so here y of x is a 0, so Green's function exists and unique over here. Okay, now we want the Green's function by using this solution. Okay, c1x plus c2. Okay, c1x plus c2. So find out the Green's function g of xt, like a1 plus a2x or a1x plus a2. Okay, anything you may feel better. Okay, a1x plus a2, and you have to take the limit from 0 to 1, because we have boundary condition y of 0 0, y of dash of 1 0. Okay, so we have boundary condition from 0 to 1. Okay, on close interval 0 1. So take this limit and convert boundary value problem into the two form, like we have c1 plus c2x. So what we do, a1x plus a2 and b1x plus b2, this is our g of xt is our boundary value problem. Okay, and our first is having condition 0x and t. Why 0xt? Because we have limit 0 to 1. Okay, so we have to take 0 to 1 limit. So for that we have to use the limit 0 to break the limit. Okay, t x1 0 to 0xt tx1. Okay, so we have to break this limit for to g1 of xt and g2 of xt. Okay, so here I define my boundary value Green's function over here. Okay, so we, as we do in our third property from Green's function, first of all we find the Green's function at t plus and t minus. Okay, this is the differentiation of n minus 2 times. Okay, so n minus 2 times means we have differentiation given in our function 2 times. Okay, so here y double dash which is equal to 0. Okay, so differentiation is a 2 times, so we have to take a n minus 2 times differentiation of our Green's function. Okay, so 2 minus 2 is 0, that means we do not have to take the differentiation. Keep our g of xt as it is. Put g of xt which is equal to x is equal to t plus, which is equal to g of xt which is equal to x is equal to t minus. Okay, so put the value t plus over here, t minus or t. Now here we have to take the t plus and t minus very carefully. Okay, because b1 of x plus b2, it is a bigger value. Okay, so 0 to t it is a smaller value than t to 1. Okay, so this one is a bigger value, so it always goes to t plus, and this one is a smaller value, always goes to t minus. Okay, so always remember this. So put the value at a point t. Okay, so a1t plus a2, b1t plus b2. Okay, so a1t plus a2, it need to be a t here, b1t plus b2. Okay, So b1t plus b2 a1t plus a2. Okay, now put this value. So take b1 minus b1 minus a1. Okay, take t term at close, b1 minus a1t plus b2 minus a2 0. Okay, bi minus ai, consider ci. Okay, so I consider here c1t plus c2. Okay, so bi minus ai, which is equal to ci, just for to make our calculation a more simplest form. That's why I converted this. Okay, so next step, n minus 1 the time of a differentiation. Okay, so g dash of xt, so n minus 1 a1 x with respect to x, it will be a1, a2 will be 0, b1 x will be 1, and b2 will be 0. So limit it will be remain same, 0 xt tx1. Okay, now dg by dx is equal to x equal to t plus dg by dx x equal to t minus minus 1 upon p naught of t. So p naught of t, which is a coefficient for our given boundary value problem. So boundary value problem, which is a y double dash plus f, which is equal to 0. So p naught of t, which is the coefficient here. Okay, but p naught of t, which is a 1 here. Okay, so minus 1 upon 1, which remain minus 1. Okay, dg by dx is x is equal to t plus, which is a b1, x is equal to t minus a1, which is equal to minus 1. Okay, b1 minus a1, which is equal to minus 1. And b1 minus a1, we have considered here b1 minus a1, which is equal to c1, and c1, which is a minus 1. Already I considered b1 minus a1, which is equal to c1 in my previous step. So c1 is a minus 1. Now put it into c1t plus c2. Okay, so you will get the c2, which is equal to t. This is coming from the differentiation at n minus 2 times. Okay, c2 is equal to t. So boundary condition, using boundary condition, find out the value for yg of 0, g dash of 1. Okay, so y of 0, y dash of 1 is equal to 0. So boundary condition compare with the g, our Green's function. Okay, so once we compare, we'll get the g of 0, which is equal to g dash of 1, which is equal to 0. Okay, so g of 0, which is equal to a2. Now what we have here, g of 0, using our given problem, we have given here g of x t a1 x plus a2. Okay, so g of 0 t, which is equal to a1 0 plus a2. So g of 0, which is equal to a2, and g of 0, which is equal to 0, that means a2 is coming 0. Okay, similarly you have to find g dash of 1. So g dash of 1, which is equal to, for the positive value, g dash of 1, which is equal to b1. So b1, which is equal to 0 here, g dash of 1, which is a 0. So here put these values over here, g dash of xt is equal to b1, g dash of 1t, which is equal to b1, and g dash of 1 we have 0, so b1 also coming 0. Okay, so I got the a2 0, b1 0, c2t, c1 minus 1. Put these values here to the c1 is equal to b1 minus a1. So a1 you will get the 1, c2 is equal to b2 minus a2, you will get the c2 is equal to b2, and b2 c2 is equal to b2, and we have c2 is the t, so we'll get the b2, which is equal to t. These are the just simple calculation that we have to work for the values for a1 a2 b1 b2. Okay, so easily you may find this one. Put the value for g of xt as a1x plus a2 b1x plus b2. So a1x, so what is the value for a1 we have here? We found the value for a1 here 1. So a1x, that means only x, plus a2 is a 0 here, b1x, b1 is 0, plus b2, so b2 is here t. Okay, and boundary condition 0xt and tx1. Okay, so these are the, this is the required Green's function g of xt. I got this here. Okay, so it is quite easier, nothing more difficult, just we have to find out the values from constant. Okay, a1 a2 b1 b2. Okay, and after solving this Green's function, so we have to move further for solution of our boundary value problem. As earlier we read it into the previous special type from Green's function, that we have to take y of x, which is equal to integral over g of xt phi of t dt. Okay, so this is the integral we have to find it out for the solution of our boundary value problem. So g of xt, so g of xt, it is a, we have for g of x 0 to t and t to 1. So convert that integral 0 to 1 as 0 to t and t to 1. Okay, so g of xt phi of t, as we have here f of t. Okay, so this phi of t, we have given f of t in our function, and f of t which is having value f in the form of t. Okay, so convert this integral for these two Green's functions. Okay, so 0 to t and t to 1. So 0 to x and x to 1. Okay, 0 to x, because integral in the form of t, so we have to take 0 to x. 0 to x t f of t dt. So g of x t f of t, g of x t we have here x into f of t dt. Okay, g of t f of t dt. So t f of t dt and x f of t dt. Okay, so t f of t dt, and x f of t dt for x to 1. Okay, so once you get this integral, just let's go for finding solution. So this is a required solution for our Green's function. Okay, and first option which says that our Green's function which belongs to closed interval 0 1. So as we have limit 0 to 1, then we say that our solution it will belongs to there. Okay, so our first option it is coming true by using our y of x. Okay, so it as it is given in our option number first. Our first option is true here. Then second option says that g of xt satisfy homogeneous equation y double dash which is equal to 0. Yes, it is satisfied. When it is satisfied, when we get the Green's function exist and unique, then and only then we will say that the homogeneous equation which is a boundary value problem for g of xt, okay, which satisfied over here. So our option C, which is already true, we already proved it into the previous part. Okay, the solution of a boundary value problem y of x, which is correct here, it is given as it is in our option D. Okay, and for the option number B, okay, so option number B here I explain option number B and option number B. So option number B which is wrong here, because g and dg by dxt are continuous. It is given in our option B. Okay, and we always know that the Green's function is always continuous. So Green's function g of xt is continuous, but we cannot say about its first differentiation, second differentiation, nth differentiation. Okay, so dg by dx is the first differentiation may be continuous or may not be continuous, but as we have given close interval 0 1 to 0 1 with the double differentiation is a discontinuity. Okay, okay, so if we wanted to check, you may take x is equal to t. So g of x2 will get the a1x plus a2, g dash you will get the a1, g double dash you will get the 0. Okay, so differentiation exists here, but not infinite. So it is a discontinuity continuity at x which is equal to t. Okay, so this is the option number B which is wrong here, and option A, C, and D which is correct over here. Okay. So I hope you all have understood my today's solution, which is completely based on the Green's function and different types of the Green's function. Okay, that we have to convert into the boundary value problem for its solution. So even after, if you do have any doubt, difficulty, let me know in the comment section. I will come up with some other videos. So thank you everyone. Thank you for my today's lecture.